A lawyer commutes daily from his suburban home to his midtown office. The average time for a one-way trip is 22 minutes, standard deviation 3.4. Assume the distribution of the trip times to be normal. What's the probability trip will take at least half hour? So half. So the thing is that the mean and standard deviation are in minutes. So this time also needs to be changed in minute. So probability. So if we let x to be the time greater than half hour. So, okay, let's just define it. Let x be the time in minutes. Let's say the commute time in minutes. Commute time in minutes. So then in part A, we want probability x is greater than 30 minutes, greater than or equal to 30 minutes. And now 30 is the value of interest, so we change that into z-score. So z is equal to x minus the mean over the standard deviation equals 30 minus 22 is the mean time over 3.4 is the standard deviation. So let's calculate it. So 8 over 3.4, 2.35. So z, we always calculate z to 2 decimal places because the tables are up to 2 decimal places for z. Okay, although interpolation can be used to get more places, but even if you get it to 2 decimal places, you should land into the correct answer. So z equals 2.35. So that means probability x greater than equal to 30 equals probability z is greater than 2.35. That will be 1 minus probability z is less than 2.35. And now we can read that one from the table. So let's look at 2.35. 2.35 is 0.9906. 1 minus 0.9906 equals 0.0094. And now, if the office opens at 9 a.m. and the lawyer leaves his house at 8:45 a.m. daily, what's the percentage of time he's late for work? So, if he leaves at 8:45 a.m., he will be late for work if he arrives in greater than 15 minutes, because by leaving at 8:45 a.m., he has to arrive within 15 minutes in order to reach the office by 9 a.m. So what we want here is probability that he's later than 15 minutes. If he takes later than 15 minutes to commute in this scenario, then he will be late. He won't be able to reach by 9 a.m. So probability x greater than 15 is needed. So now we change 15 into z-score. So z is equal to 15 minus the mean of 22 over 3.4. So negative 7 over 3.4. 2.06, negative 2.06. And now that means that probability z is greater than negative 2.06 is what we need. And we change it into, so that's the same as probability z is less than 2.06. because on the normal curve, if you look at this, let's say negative 2.06 is here. Probability z greater than negative 2.06 is this one. And then if we draw positive 2.06, and find the probability less than positive 2.06, that is equal to this one. This area is the same as this area by symmetry. So z is less than 2.06. That can be read directly from the table. And 2.06, 0.9803. 0.9803. And you change that to percentage, so 98.03 by multiplying by 100. If he leaves the house at 8:35 and coffee is served from 8:50 a.m. to 9 a.m., what's the probability that he misses the coffee? So basically, he will miss the coffee if he arrives later than 9 a.m. As long as he arrives before 9 a.m., he should be able to get the coffee. Even if he arrives earlier than 8:50, he'll just wait because the office doesn't start until 9. And so he will still get the coffee. So although they didn't mention clearly, they're making the assumption here that the office doesn't start until 9. So even if he arrives before 8:50, he'll wait a few minutes and get coffee. And so as long as, so the thing here is that this 8:50 is not going to be used because the point is to get the coffee, he should arrive within 9 a.m. And if he arrives after 9 a.m., then he doesn't get the coffee. So 8:30, between 8:35 and 9, there are 25 minutes. So he will miss the coffee if it takes him longer than 25 minutes, because he starts at 8:35. To get the coffee, he should be within 25 minutes to get till 9 a.m. And if he's longer than 25 minutes for his commute, then he will arrive after 9 a.m. and so miss the coffee. So what we really need here is probability x is greater than 25. So let's change now 25 into z-score. So 25 minus the average is 22 over 3.4. So 3 over 3.4, 0.88. So we need probability z is greater than 0.88. That's 1 minus probability z is less than or equal to 0.88. This we can get from the table directly. 0.88. 0.88 is 0.8106. 0.8106. So 1 minus 0.8106 equals 0.1894. Find the length of time above which we find the lowest 20% of trips. So length of time above which the lowest 20% of trips. So the lowest trip means a trip which takes the greatest time. The slowest trip means the trip which takes the greatest time. And so we want the length of time above those. So the 20% area on the right is this. And any times that are equal to or greater than this mark text, which cuts off the 20% area, these will be the slowest 20% trips. So the slowest 20% trips will actually be the upper 20% region of the time curve, because slower trip means higher time. So this is the picture that we are looking at. So we are looking at an area of 0.2. So, but the thing is, this is a right area. We need the left area. So the left area is 0.8. The left area is needed in order to read the normal curve that is given in the SOA. So if we look at an area of 0.8, so remember now we are looking at 0.8 in the area region. So let's try to find 0.8. Now we don't quite find 0.8. We are finding 0.7995 and 0.8023. Now, in these kind of situations, when you don't find the exact area you are looking for, linear interpolation should be done. And so we see that 0.84 corresponds to, so you look at the two values, one below and one above the value that you need. We need 0.8. So the one below it is 0.7995, that corresponds to 0.84. And the 0.8023 corresponds to 0.85. 0.7995 corresponds to 0.84. And 0.8023 corresponds to 0.85. And by interpolation, we actually try to find the third decimal place, because we know it's somewhere between z equals 0.84 and z equals 0.85. And normally, even if you just find a third decimal place, that should be a good enough interpolation. So what we will do is, in interpolation, we first write the value that we need. So we are interested in 0.8. And so from it, we subtract the lower of the values, 0.7995. And on the bottom, you have highest minus lowest. So highest was 0.8023 minus 0.80 minus 0.7995. So let's see. So this gives us 0.8 minus 0.7995 be 0.0005. 5 over 28. So we get 0.18 or 0.2. Correct to one decimal place. So what that means is that the third, and then you look at the lower of the two z values, so, and put that 0.2 that you got in the third decimal place. So 0.842 is the z value you need. So we want the x value. So the z value is 0.842. So again, the value of interest minus the lower probability divided by higher probability minus lower probability. That gives you the third decimal place starting from the lower z value, so 0.842. Okay. So z equals 0.842. Let's open a new one. So z equals 0.842. But you want the minutes, which means you want the x. So we know the formula, z is equal to x minus the mean over the standard deviation. So 0.842 equals x minus 22 over 3.4. So 0.842 into 3.4 plus 22. Let's get 24.9. Oh, they need 3 decimal places. So let me change my calculator to more decimal places. Or let's just look for a calculator here. So what I need is 0.842 times 3.4, 0.842 times 3.4 plus, so this moves over here, and then we add the 22. It's 22, 24.863. So 24.863. Okay, find the probability that 2 of the next 3 trips will take at least half hour. So now this is a binomial distribution because we are talking about either taking at least half hour or taking less than half hour. So we can say here that we are now in a binomial situation. And n is equal to 3 because we are talking about a total of 3 trips and we want 2 of them, so x equals 2 of them to take at least half hour, and the probability of 1 of them to take at least half hour was calculated in part A, probability for trip to take at least half hour, so that's 0.0094. That's for 1 trip to take at least half hour, and we want the probability that 2 of the 3 trips take at least half hour, so binomial. So we know that the f of x in case of binomial is ncx, p of x, 1 minus b, n minus x. So in this case, it would be 3c2 and p of 2. So 0.0094 power 2, and then 1 minus 0.0094 would be 0.9906, and n minus x would be 3 minus x, which would be 1. Okay, so 3c2 is just 3, so 3 into 0.0094 squared, 3 into 0.0094 squared, and then times 0.9906. Okay, 0.00026. And correct to 4 decimal places. Okay, 0.0003.